Hello, everyone. Welcome to today's lesson, Tolerance Item Evaluation for Plate Parts. In previous lessons, we have already learned how to use the constructing function to calculate data from measured elements, and thus construct corresponding features. Today, we will delve into how to perform dimensional evaluation on plate parts to ensure that products meet design requirements. Through this lesson, I hope you can accurately understand the requirements of tolerance item evaluation for plate parts, independently use related software to complete the evaluation settings for 6 key dimensions, correctly execute automatic measurement and evaluation programs, obtain and interpret the actual dimension measurement reports of workpieces, ensure the accuracy and reliability of measurement results, and make necessary adjustments and optimizations based on the reports. Next, I will lead you through a practical case study to learn this skill in detail. Next, we will proceed to the next step, dimension evaluation. Before conducting dimension evaluation, similarly insert report, command, comment. Click on document and add the comment content. The following is the dimensional evaluation section. Identify the first dimension as the distance in the y direction. First, confirm that its working plane is not in the y direction, then click Insert, Dimension, Distance, and change its ID to D001. Next, select the associated features reference plane C and plane 1, choose 2D, and check along y direction. The upper deviation is 0, and the lower deviation is negative 0.03. Click Create. The second dimension is the distance in the z direction. At this point, you need to switch the working plane to either x or y direction. Choose x positive direction here, then insert dimension, distance. Select the associated features reference plane B and cylinder 1. Choose 2D, and check z direction. The upper deviation is positive 0.1, and the lower deviation is negative 0.1. Click Create. The third dimension is position tolerance. Insert dimension, position degree. First, define the reference and change its identifier to P003. Select threaded hole M10 and CYO2, and add references A, B, C. Change its tolerance value to Phi 0.2. In the theoretical value, uncheck all unnecessary information. Click Create. The fourth dimension is the cone angle. Click Insert, Dimension, Position and change its ID to A004. Select the cone, check angle and half angle. The upper tolerance is 0.1, and the lower tolerance is minus 0.1. Click Create. The fifth dimension is the distance in the y direction. Click Insert, Dimension, Distance. Select reference plane C and cylinder 1. Choose 2D for distance type, and check along the y-axis. The upper tolerance is 0.1, and the lower tolerance is minus 0.1. Change its ID to D005. Click Create. The sixth dimension is parallelism. Insert dimension, parallelism. Select plane 2, change its identifier to PA006, set its tolerance to 0.02, and add reference A. Click Create. The automatic measurement and evaluation part of the program has been completed. Select this part of the program, use the shortcut key Ctrl+E to execute it on the workpiece. Obtain the actual dimension measurement report of the workpiece, and view or print it. For specific operational steps, refer to previous tasks. Through this lesson, we have mastered the basic steps and methods for evaluating tolerance items and plate parts. You can accurately understand the evaluation requirements, independently use the relevant software to complete the evaluation settings of key dimensions, and correctly execute automatic measurement and evaluation programs to obtain and interpret the actual dimension measurement reports of workpieces. I hope that in your future work, you can proficiently apply the knowledge learned to ensure the stability and reliability of product quality. Finally, Please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This concludes our lesson. See you next time.